Today, on how it's made. Audio vacuum tubes. Light bars. Wood model aircraft. And metal snare drums. When it comes to sound quality, audiophiles swear by amplifiers which contain vacuum tubes to boost and modify the electrical signal. They were the norm till transistors came along in the 1950s. Many audio enthusiasts still prefer tube sound, which they find warmer, richer, and more natural. Once standard in radios, phonographs, and televisions, today you see vacuum tubes only in very high-end audio equipment. They come in an array of models designed to perform specific sound-enhancing tasks. Technicians at this Czech factory first wind wire a precise number of revolutions with a very specific degree of tension. Then they clean the surface and weld it to a support structure. This completes the grid, one of the tube's main components. Next, technicians take the second main component, the cathode, and insert it into the grid. When the sound signal enters the tube, the cathode produces a flow of electrons. The grid controls that flow as it travels to the third main component, the anode. The anode's top-secret black coating increases the effect of the electrons hitting it, causing the anode and cathode to have two different voltages, both of which are greater than that of the original signal. This makes the signal larger and more powerful, meaning it amplifies the sound. With those three key components now assembled into one unit, the inside structure of the tube is complete. Now for the bulb, which will encase that unit. A glass blower skillfully crafts it out of hard, laboratory-grade glass. Using a high-temperature torch and glass-making tools, he melts the open end and seals it off. Then he blows in a bit of air to shape the end into an evenly rounded dome. Now he mounts the bulb on a lathe to complete the shaping. Keeping the glass evenly heated, he blows in just enough air pressure to keep the bulb from collapsing inward. When the glass reaches just the right temperature, a die presses against it, setting the final shape. Next, they mount a glass collar over copper wires clamped into a motorized vise, then insert a glass straw called an evacuation port. As the vise rotates, they heat the collar uniformly with stationary torches. Using a handheld torch, they remove any stretches or runs in the softening glass. When the time is right, they activate a die to press the glass into the final shape. This completes the stem on which the tube's inside structure sits. The wires protruding from the top of the stem connect to the structure's terminals. Now they put this assembled unit on a turntable and center the bulb over it. As the turntable revolves, they heat the bottom of the bulb. As the glass melts, they press it inward, fusing it to the stem. They remove the excess glass and continue heating to ensure the bottom is fully sealed. Next, they prepare to suction out the air. This step is critical to the tube's performance because air molecules hinder the flow of electrons. Technicians fuse the tube's evacuation port to the glass evacuation line of a vacuum pump. The pump then extracts the air through the port. At the same time, they heat the tube in a pull-down oven. This increases pressure inside the tube, creating a stronger vacuum. Next, they run an inductive heater over the tube. This dislodges damaging impurities, enabling the vacuum pump to draw them out. They target the stem area with a second inductive heater, to draw particles called ions onto the glass permanently so that they can't later damage the tube. Finally, they connect the protruding wires to a plastic plug-in base. There are subtle technical differences between tubes of the same model, so the factory tests each tube, then matches pairs with similar performance features. This ensures they'll amplify sound evenly. A light bar is that strip of flashing lights on top of a police car or emergency vehicle. The lights are high-output LEDs, far more efficient and durable than incandescent or quartz halogen bulbs or strobe tubes. The mounting system is designed to withstand emergency high-speed driving. The LEDs are grouped by color within a module. Modules can be arranged in any configuration on the light bar base. The base mounts to the vehicle's roof via straps made of high-strength stainless steel. Those straps begin as flat pieces, laser cut to a starting shape. A 50-ton forming press bends them to the final shape, which fits the exact contour of the vehicle's door jamb. The light bar's white light modules fasten onto the base with the aluminum brackets this worker is assembling. These brackets also help draw out the heat the lights generate. This is critical because if LEDs overheat, they burn out. The base is made of extruded aluminum. This computer-controlled laser, working on 6 bases at a time, cuts out holes for venting and cables. The light bar has 2 cables, one running power from the vehicle's battery to the light bar, and another connecting control switches on the dashboard to the light bar's electronic control board. An automatic machine measures and cuts the required length of each cable, then strips off a specific amount of the PVC outer jacket at both ends. This exposes 3 wires, 2 of which are insulated and inside a foil wrap. After stripping off the foil, an automatic stripping machine removes some insulation bearing the tin-coated copper wire within. Workers put contacts onto 2 of those wires, the ground and the power. Then press the contacts on securely with a crimping device. Next, they connect a terminal to the 3rd wire, the shield drain. This wire reduces electronic interference from sources like the police radio. Now for the LED light modules, the main component of which is a reflector. They put the reflector's plastic body into the sealed chamber of a metallizing machine. The machine then releases argon gas, while applying hundreds of volts of electricity to a solid piece of aluminum. This vaporizes the metal into tiny particles, which a vacuum draws onto the plastic body in an ultra-thin reflective coating. To broaden the horizontal range of the reflection, workers install a device called a collimator. Then they take an LED light, put an electrical insulator on the back of it, and mount it inside a housing that's specially designed to remove heat from the LEDs. Then they install these assembled light components in the reflector. Install the connector that plugs into the wire harness that leads to the control board, and test the finished module. To assemble the light bar, they slide the control board onto the base, plug in the control cable that connects the board to the dashboard switches, install the power cable that runs from the vehicle's battery to the light bar, and the wiring connecting the lights to the board. After mounting the white light modules on the brackets and securing them to the base, workers take the colored LED modules and slide them onto the tracks on the base. They make the internal connections to the control board, then plug each module into the control board harnesses. After testing to make sure everything works properly, It's just a matter of encasing the modules, starting with an aluminum top, then slide on transparent plastic lenses, with divider gaskets in between to prevent rain from penetrating and shorting out the light. A cap closes up each end. After a final round of testing, the light bar is ready to hit the roof and the road. Flying a Wood model aircraft is a way to experience the adventure of flight on a small scale. But there's a lot to do before takeoff. These miniature planes usually come in kits that can take dozens of hours to piece together. But of course, that's just part of the fun. Wood model planes are part of aviation history. The first real flying machines were made of wood, and soon after their invention, people began building miniature wood replicas in kit form. Today, modern manufacturing techniques take the concept to a whole new level. Production begins with blocks of wood that circle on a system of conveyors. Each time around, a long blade slices away a thin piece. They transfer the sheets of wood to a table that moves in a computer-choreographed sequence while lasers overhead make cuts. This computerized system produces parts that will fit together perfectly, no matter how intricate the design. To assemble the kit at home, the modeler extracts the pre-cut parts. He then builds the fuselage right on top of the plans in order to follow them to the letter. After the fuselage has been assembled, he focuses on the wings. He braces the main spar with numerous ribs to create a cross-sectional airfoil that will generate lift. He then glues the wing's leading edge to the framework. The framework is very similar to that of full-sized wooden wings built in the early days of flight. It's made mainly of tropical balsa, a wood that's both lightweight and exceptionally strong. The modeler joins the two wings. The tongue of one fits into the laser-cut slot of another. This joint will later be glued to reinforce it. He demonstrates the next step, using the wing of another model. He drapes plastic film over the wing skeleton. He tacks the plastic to it and smooths out ripples and bubbles. He then heat shrinks the plastic to give the model aircraft its tight skin. Of course, there's no need for a paint job because the plastic is tinted. Finally, he confirms that it's drum tight. Back on the production line, they're now winding wire to produce a spring. This spring is a shock absorber for the plane's front landing gear. With that complete, they now position a sheet of preheated plastic above 6 molds of wheel covers. He activates a vacuum that pulls the plastic over the molds. In seconds, it cools and solidifies into the shape of the wheel covers, called pants. With the wheel pants assembled to the craft, the modeler now installs the 2-stroke alcohol-burning engine in the front compartment. He attaches the muffler to the engine's crankcase. He then secures the spinner's backplate and propeller onto the engine's drive shaft with a washer and a bolt. This assembly will have to withstand the force of the spinning propeller, so he tightens it to the max. This model plane is now ready for flight. Incredibly, it started out as a bunch of parts in a box, but they all come together in the hands of a skillful modeler. Of course, A good set of instructions is essential. Assembling each model can take up to 50 hours. We've just shown the highlights. The payoff comes when the operator manipulates the transmitter joystick and the parts of the plane move right on cue. From fighter planes and biplanes to civilian aircraft and extreme aerobatic machines, when it comes to these historical replicas, the sky really is the limit. The sound of a snare drum is unmistakable, a sharp rattle with a somewhat tinny resonance. What produces this distinctive sound? It's a vibrating set of wires, called the snare wire, stretched across the bottom of the drum. The snare drum is usually the center of the drum kit. The circular frame of a snare drum, called the shell, can be made of either wood or metal. Metal shells produce a sharp, loud, and more brilliant sound. The metal this German drum company uses is known as Bell bronze, which is approximately 78% copper and 22% tin. Workers first glue together a 3-part mold. It's made of a sand and chemical mixture because sand can withstand the temperature of the hot molten metal. The glue sets in about half an hour and the mold is ready. They steady it with heavy steel plates, then scoop a bucket full of Bell bronze from the furnace and pour it in. It took 4 hours at 1260 degrees Celsius to melt the metal, but just a few seconds for it to solidify inside the mold cavity. They let the casting cool for a couple of hours, then break the sand mold to extract it. They clean off the loose sand with a wire brush, then ship the shell to the drum factory, where its first stop is onto an automated lathe. As the lathe spins, a cutter skims off a thin layer of metal, making the shell's exterior surface clean and smooth. Next, a computer-guided drilling machine bores 47 holes for various components, including fittings that hold and adjust the drum heads and a vent hole which increases the drum's volume. Then the machine changes the drilling tool for a milling tool and makes 2 recessed areas, called snare beds, in the shell's bottom edge. The drill left rough edges, so they clean and smooth the holes with a small grinding tool. Then they manually sand the snare beds. Next, they sand the shell's outside surface, first with a rough abrasive belt, then with a fine one. This leaves the metal shiny and silky smooth. Now they sand the inside surface by hand. They spray it with a bronze-colored lacquer to give the metal an even color and prevent tarnishing. They taped over the holes to keep the colored lacquer from hitting the outside surface. Now they remove the tape and spray the outside with transparent lacquer, which allows the natural color of the metal to show through. 25 minutes in an oven hardens the lacquer into a super durable finish. Then final assembly begins, starting with the tension lugs, the fittings which hold and adjust the tension of the drum heads. Next comes the action strainer, the mechanism the drummer flips up or down to activate and deactivate the snare sound. The top drum head is made of a strong polyester material. A chrome-plated metal hoop will hold the head to the shell. To tune the drum to a higher or lower pitch, the drummer tightens or loosens the screws to increase or decrease tension. Drumhead tension determines pitch. The bottom drumhead is made of clear polyester film. It's much thinner than the top drumhead to enable the snare wire to respond faster. That snare wire is made of multiple strands of stainless steel, brass, or copper wire. They stretch it across the bottom head, laying each end on a snare bed. They attach the ends with nylon cords to the action strainer on one side and to a part called the butt end on the other. To play the drum with a snare sound, the drummer simply pulls up on the action strainer's handle. Every drum undergoes a final inspection, then tuning and a thorough performance test. Talk about ending with a bang.